Shams of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This is a great place for you to practice all your entrance exam question papers because all detailed PDF solutions are available there. For a better preparation of your exams, you must download our app. The link is available in the description box. Students, today I'll be solving CBSE class 12 chemistry 2023 outside Delhi set 1 paper. I'll be solving all the chemistry questions in this particular video. So here we start with question number 1. A very best of luck. Here we go. Section A, it says the conversion of an alkyl halide into alkene by alcoholic potassium hydroxide is classified as. See, when an alkyl halide it is treated with the alcoholic potassium hydroxide, removal of hydrogen halide takes place. This takes place, this results in the formation of alkene. Alkene is formed. This type of reaction is dehydrohalogenation reaction. This reaction is an example of dehydrohalogenation, that is beta elimination reaction. Let's write down the reaction for this. This is given by, suppose you have CH3, CH2, X halogen attached in the presence of alcoholic potassium hydroxide, it gives you alkene plus hydrogen halide. So this is the dehydrohalogenation reaction, as it is accompanied by the removal of one halogen from here, which gets attached with the hydrogen atom. So we have B option as the correct answer. Hope you understood this. Let's move to the next question, number 2. The oxidation state of iron in this is the oxidation state of the carbonyl group in the given molecule is 0. Oxidation state is 0 of carbonyl group, which is 0. So let the oxidation state of Fe be X. Therefore, you will have X plus 5 into 0 is equal to 0 because this is a stabilized molecule. So you have X plus 0 is equal to 0. That gives you X is equal to 0. Therefore, the oxidation of state of iron in the given molecule is 0. That makes B option to be the correct answer. Hope you understood this. Next is question number 3. Among the following, which is the strongest base? These are the given options, and which one is the strongest base? Is option C. Methylamine shows plus I effect. As a lone pair on the electron on the nitrogen atom is delocalized and not involved in resonance. So you have this vinyl option C as the right answer. Question number 3, among the following, which is the strongest base? So you have to find out which is the strongest base from here. Phenyl, option C. This is the strongest base. Here the methylamine shows plus I effect. As a lone pair on the of electron on the nitrogen atom is delocalized and not involved in resonance. Is delocalized and not involved in resonance. So you have option C as the right answer to the question. Hope you understood that. Let's move to the next question, number 4. It says the slope of the plot of log R versus time for the first order reaction is. See, you have the reaction R, like this reaction gives you some products. The integrated first order reaction is given by integrated first order rate equation is given by natural log R is equal to minus KT plus natural log R naught. Comparing it with the equation of the straight line, which is y is equal to mx plus c, you have y as the natural log of R, x as t. Here the slope is minus k. And the intercept will be given by, intercept is this. So the slope of the first order rate reaction is minus K. That makes B option to be the right answer. Hope you got that. Let's move to the next question. 5. An alpha helix is a structure feature of sucrose polypeptides, nucleotides, or starch. The right answer is polypeptides, option B. An alpha helix is a structural feature of polypeptides. In this structure, the NH group of amino in one turn is twisted and stabilized by the hydrogen bond and with the carbon group of amino acids. It's the secondary structure of the protein. So you have option B as the right answer to the question. Hope you understood this. Let's move to the next question, number 6. It says racemization occurs in SN1 reaction, SN2 reaction, neither of them, or SN2 reaction as well as SN1 reaction. The right answer to the question is you have the first option, SN1 reaction, a mixture containing two enantiomers. Question number 6. Racemization occurs in SN1 reaction, SN2 reaction, neither of them or in both of them. Well, the correct answer to the question is option number 1, SN1 reaction. A mixture containing two enantiomers is in equal proportion will have zero optical rotation. As the rotation due to one isomer will be cancelled by the rotation due to another isomer. Such a mixture is called racemic mixture. Or racemic modification. The process of conversion of enantiomer into racemic mixture is known as racemization. In SN1 reaction, both retented and inverted products are formed due to the production of both D and both due to the product of D and both due to the production of D and L product. This racemization occurs. So we have first option A as the right answer. Hope you understood. Next is question number 7. The value of Henry's constant Kh increases with decrease in temperature, decreases with increase in temperature, increases with increase in temperature, or it remains constant. The right answer, it increases with increase in temperature. According to Henry's law, at a constant temperature, the solubility of the gas in liquid is gas in liquid is directly proportional to the partial pressure of the gas. Let's say that is X of the gas present above the surface of the liquid or the solution. Or you can say P is equal to KH into X, where KH is the Henry's constant, which typically increases. This is Henry's constant. It typically increases with temperature at low temperatures, reaches a maximum and then it decreases. It increases with increase in temperature at low temperatures. Then it reaches a maximum. And after that, it decreases at higher temperatures. All right. So that makes option C to be the right answer. It increases with increase in temperature. So you have option C as the right answer. Hope you understood this. Next is the question number 8. Which of the following solutions of KCl will have the highest value of the molar conductivity? You have 0.01 m, 1 m, 0.5 m, or 0.1 m. The right answer to the question, for that let's solve. According to the relationship between specific conductivity and molar conductivity, and molar conductivity, you have the molar conductivity is equal to this centimeter cube per liter. From the above equation, the molar conductivity is inversely proportional to the molarity of the solution. Therefore, the lesser the molarity, more will be the molar conductivity, right? So you have a first as the right answer because this is the least value. The least value will give you the highest value for the molar conductivity. That is option A. This is the right answer to the question. Hope you got that. Let's find which following reactions are feasible. These are the two reactions which are given to you, and you have to find out which of these two are feasible, or both of them, or none of them. See, if I read out the first one, if I see the first reaction, this is feasible. This is an example of Williamson synthesis. Williamson synthesis. In this method, an alkyl halide is allowed to react with the sodium alkoxide, and it involves SN2 attack of an alkoxide on the this primary alkyl halide over here. So this attacks, and this nitrogen and bromine, they separate out, and this attaches over here, giving you this as a product. Whereas in the second one, this option B, elimination will take place. Elimination will take place where alkene and alcohol and sodium halide will be the product, will be as your products. So this reaction is not feasible. That makes first option, option A, to be the correct answer to the question. Hope you understood this. Next is question number 10. Which of the following is the most reactive in nucleophilic addition reactions? Formaldehyde, or these four options are there. The right answer to the question, option A, formaldehyde. Reactivity towards the nucleophilic addition reactions are influenced by the group attached to the carbonyl atom, this carbon atom. More electron deficient, more carbon, more is the reactivity of the carbon. Presence of the alkyl group, presence of this alkyl group decreases the reactivity by decreasing electron deficiency. Hence, formaldehyde, this is the most reactive towards the nucleophilic addition reactions, and this is the right answer to the question. Hope you understood this. Next is question number 11. Which of the following does not give aldol condensation reaction? These options are there. And which one does not give you? Let's see over here. Aldehyde, that is option 2. This does not give you aldol condensation reaction. Aldehydes and ketones having at least one alpha hydrogen undergo reaction in the presence of dilute alkali as a catalyst to form beta hydroxy aldehydes, aldols, and beta hydroxy ketone, respectively. This is called your aldol condensation reaction. Benzaldehyde, due to the absence of alpha hydrogen, does not undergo the aldol condensation, and therefore this is the right answer to the question. Hope you understood this. Now let's move to the question number 12. For the reaction 3A to 2B, the rate of reaction plus dB upon dt is equal to what? Okay, see, the rate of reaction is given by minus 1 upon 3 dA upon dt. This is equal to, according to this reaction, this is equal to plus 1 by 2 dB upon dt, right? So from here you have a dB upon dt is equal to minus 2 by 3 dA by dt. So the rate of reaction, here is, okay, plus this is equal to option B. This is the right answer to the question. Hope you understood this. Next is question number 13. Which of the following characteristics of transition metals is associated with their catalytic activity? Paramagnetic nature or colorful color of the hydrated ions, high enthalpy of the atomization, variable oxidation states. The right answer to the question, option D, variable oxidation states. Transition metals have tendency to show variable oxidation state to form unstable intermediates and intermediates and provide new path with lower EA for the reaction. Therefore, transition metals show catalytic activity. So that means variable oxidation states. This is the right answer to the question. Option D is the correct answer. Hope you understood this. Let's move to the next question. Formula for the complex dichlorobis ethane 1,2-diamine platinum 4 nitrate is given by. Let's formulate it. So you have platinum 4. So this is PT. Then it will be dichlorobis. So this is the one. Ethene 1,2-diamine. Okay. This is and then nitrate. Right. This is the right answer to the question. And now let's check. You have B option as the correct answer. Hope you got this. Let's move to the next question number 15. Assertion says osmotic pressure is a colligative property and the reason for this is osmotic pressure is proportional to molality. Well, the assertion is correct. Osmotic pressure is a colligative property. That is right. But the osmotic pressure is proportional to molar concentration, not molality. See, the osmotic pressure of a solution at any temperature depends on the molar concentration and not on the molality. That makes the reason to be false, but the assertion is correct. Hence, you have the option C as the correct answer to the question. Hope you got that. Let's move to the next question, number 16. Assertion says conductivity decreases with the decrease in concentration of the electrolyte. Reason says number of ions per unit volume that carry the current in a solution decreases on dilution. So which of the assertion and reason they are correct? Let's see. Since on dilution, if I look at the assertion, it says conductivity decreases with the decrease in concentration of the electrolyte. See, if I'm diluting the number of ions per unit volume, on dilution, the number of ions per unit volume decreases. Therefore, current carrying capacity of the solution also decreases. And what will happen if the current carry capacity will decrease, the conductivity will decrease. So conductivity decreases with the decrease in concentration of the electrolytes, obviously, because the number of ions per unit volume will decrease. This is right. And the reason says the number of ions per unit volume that carry the current in a solution decreases on dilution. This is also correct. So that means the assertion is correct and the reason is correct explanation for that assertion. So you have first option as the right answer. Hope you got that. Next is question number 17. Again, assertion and reason question. Copper is a non-transition element. Copper has completely filled d orbitals in its ground state. First thing, copper is a non-transition element. This is wrong. Copper is a transition metal due to the presence of copper is transition metal due to the presence of incompletely filled d orbital in its common oxidation state. Let's see. That is Cu plus 2. So this is 3d9. While in the ground state, the electronic configuration in the ground state, electronic configuration of copper is 3d10 4s 1. So copper has completely filled d orbitals in the ground state. This reason is correct, but the assertion is wrong. It is not a non-transition. It is a transition element. Okay. So you have D option as the correct answer. Assertion is false. Reason is true. Hope you understood. Next is question number 18. Nucleophilic substitution of iodoethane is easier than chloroethane. Reason says bond enthalpy of Ci bond is less than that of CCl bond. Well, if I look at the assertion, iodine is better leaving group due to of its larger size. It will be released at a faster rate in the presence of incoming nucleophile as compared to chlorine. So you have this assertion as correct. Nucleophilic substitution of iodoethane is easier than chloroethane. That's right. Bond enthalpy of Ci is less than this. That's why it may break very easily. So you have first option as the right answer. Hope you understood this. Next is question number 19. So this is section B. It says the vapor pressure of pure liquid X and the vapor pressure of Y at 25 degrees Celsius is given by this and this respectively. If equal moles of X and Y are mixed to form ideal solution, you have to calculate the vapor pressure of the solution. Okay. So first thing you are given at 25 degrees Celsius, the vapor pressure of X is given by 120 mm mercury. So let's write it down. At 25 degree Celsius, pure vapor pressure of X is given by, let's write it like this. This is equal to 120 mm mercury, and for Y this is given by, let's say this is 160 mm mercury. Let the number of moles of let the number of moles of liquid X and Y be N. So you have X is equal to N upon N plus 1. That is the portion of X moles in the whole solution is given by 1 upon 2. Similarly, you are sorry. The pressure of the pure liquid X and the pure liquid Y at 25 degrees Celsius are 120 mm mercury and 160 mm mercury respectively. If equal moles of X and Y are mixed to form ideal gas, you have to calculate the vapor pressure of the solution. So you are given that at 25 degrees Celsius, pure vapor pressure of liquid X and Y are given by Px. Let's say this is equal to 120 mm mercury, and for the pressure Y, this is equal to 160 mm mercury. Now let the number, because you are given that equal moles of X and Y are mixed to form ideal situation. So let's say the number of moles of X and Y be, like, let's say this is equal to N. So what will be the concentration of X? This will be given by N upon N plus N, that is equal to 1 by 2. And you are given that they X and the concentration of X and Y, they are having the equal number of moles. So that means XX is equal to XY, that's concentration of X and Y in terms of moles. This is equal to 1 by 2, or this is equal to 0.5. Now the total vapor pressure is given by Pt is equal to P of P naught X into the concentration of X. This is equal to X naught into concentration of X, Py naught into concentration of Y. This is 120 into 0 0.5, 160 into 0 0.5. This is 60 and 80, that is 140 mm of mercury. So this is the right answer to the question. You are not given the options over here. This is the right answer. Hope you understood this. Next is question number 20. So you are having a choice over here. Give reasons mercury cell delivers a constant potential during its lifetime. In the experimental determination of the electrolytic conductance, direct current DC is not used. Okay, you have to give the reasons for the first one. The mercury cell delivers a constant potential during its lifetime. In the mercury cell, the overall reaction does not involve any ion in the solution, whose concentration can change during its lifetime. Due to this, its potential remains, let's write it down. In the mercury cell, overall reaction doesn't involve any ions in the solution. So no concentration of the ions will take place. So no change in concentration of ions can take place. Therefore, the potential of 1.35 volt, it always remains the constant. This is the reason for the mercury cell delivers a constant potential during its lifetime because of the absence of the ions. The second one, it says in the experimental determination of the electrolytic conductance, DC is not used. In the experimental determination of the electrolytic conductance, if direct current is used, it can cause polarization of the electrodes. If direct current is used, it can cause polarization of electrodes and electrolyte, resulting in error in conductance measurement. So, DC is not used. All right, hope you understood this as well. Now, or, that is the second part for this question. Define fuel cell with an example. What advantages do the fuel cells have over primary and secondary batteries? Okay, so you have to wait. Okay, you have to define the fuel cell with an example first thing, and what advantages do these fuel cells have over the primary and the secondary batteries. So let's go with this. First is these galvanic cells that are designed to convert energy of combustion of fuels like hydrogen, methane, methanol directly into the electrical energy. These are called the fuel cells. For example, like cells like hydrogen cells, oxygen, H2O2, O2 cells. Some advantages of the fuel cells, they include efficiency percentage of the fuel cell is about 70%. The cell works continuously as long as the oxidizing agent like oxygen and reducing agent like hydrogen, they both are supplied. And of course, no pollution, they are eco-friendly. So these are some of the questions. These are some of the advantages. Hope you are clear with this. Let's move to the next question, number 21. The conversion of a molecule A to B followed by second order kinetics. If concentration of A increased to 3 times, how will it affect the rate of formation of B? B says you have to define pseudo first order reaction with an example. Okay, so first one, the conversion of a molecule A to B followed by the second order kinetics. If the concentration of A is increased 3 times, how will it affect the formation of B? Let's write it down. So according to the question, this is a second order kinetics. So you have 2A gives you B. Here the rate will be given by K into the concentration of A square. When the concentration of A is increased to 3 times, so when concentration of A is increased to 3 times, you have rate as Ka dash square, or here you have A dash is equal to concentration is increased 3 times, A dash is equal to 3A. So therefore the rate next rate, new rate, this is given by 3A square, or this is 9K concentration of A square. This is equal to 9 times the original rate, right? So that means the rate of formation of B increases by 9 times. This is the right answer. Hope you understood this. Let's move to the next question then. The second part of the question. Define Surya first order reaction with an example. When a reactant of a bimolecular reaction is taken in excess, the concentration does not affect the rate of reaction. Such reactions are the pseudo first order reactions. Let's write it down. When a reactant of a biomolecular reaction is taken in excess, its concentration doesn't affect the rate of reaction. Such reactions are pseudo first order reactions. For example, inversion of cane sugar is pseudo first order reaction. It is something C12H22O11 water. This gives you C6H12O6, and this is glucose and fructose. Here, rate is given by K into the concentration of C12H22O11. So, hope we are clear with this. Next is the question number 22. Write the IUPAC name of the following. These are the two ions. This is the ion given to you, and this is the second one molecule. You have to tell the IUPAC name for this, both of them. For the first one, you have this one. This one is having the name as pentaamine nitrato O cobalt 3 ion, right? So this is pentaamine. This is amine group. This is occurring 5 times. This is pentaamine nitrito. This is nitrito O cobalt 3, because here the valency is given by the cobalt is having the valency of 3, so 3 ion. The next one, the second one, this is okay. So now the second one, this is potassium tetrachlorido nickelate 2. Okay, this is potassium tetrachlorido nickelate 2. So hope you're clear with this. 2 is like it is defining the valency of this, or it is defining, okay, it is defining the power of this. Now, question number 22, write the IUPAC name for the following ion and the molecule. Let's see the first one. This is having the name as, this is pentaamino. This is amino group. This is occurring 5 times. Pentaamine nitrito O cobalt 3. This is an ion, so I will write down the ion. This is an ion. So this is pentaamine nitrito O cobalt ion. Okay. Now the second one. This one. This is, of course, let's write down the name. This is potassium tetra. This is tetra because chlorine is occurring 4 times. Tetrachlorido nickelate 2, because here is 2, so this is nickelate 2. Hope you're clear with the names. Next is okay, or part, or this is the choice. This is asking what is the chelate complex. Give an example. When a di or polydentate ligand uses its two or more donor atoms simultaneously to bind a single metal ion. A single metal ion, it is said to be a chelate ligand. Such complexes, they are called the chelate complexes. For example, you can have COCl2En2 plus. Okay. So this is a chelate complex. And the second one, what is a heteroleptic complex? You have to give one example for this as well. The complexes in which the metal is bound to more than one kind of donor groups, they are heteroleptic complexes. Complexes, B part. In which a metal is bound to more than one kind of donor groups. They are called this is heteroleptic complexes. So let's see one example of it. This is CONH3OCl2 plus. This is C capital. Okay. So this is the right answer to the question. Hope you're clear with this. Next is the question number 23. You have to write the chemical equation involved in the following reactions. These are the two reactions. You have to tell the chemical equations which are involved in this. Question number 23. Write the chemical reaction equation involved in the following reactions. The Riemann-Damon reaction and the acetylation of salicylic acid. The first one, the Riemann-Damon reaction. This is used for orthoformylation of phenols. Formylation of phenols with the simplest example of conversion of phenol to salicylic. Let's go for the writing the reaction. You have phenol over here. In the presence of CHCl3 aqueous sodium hydroxide, it gives you the intermediate as this. ONA will be attached over here, and here you will have CHCl2. And this is your intermediate which is formed. On further reaction with sodium hydroxide, this will be over here. This is O and A positive over here, and CHO will be attached over here. And on further reaction, the presence of hydrogen ions, it will give you salicylic. Here will be OH, CHO. This is salicylic. So this is a example of Riemann-Damon reaction. Now the second one, that is acetylation of salicylic acid. Let's write on that as well. So this, write on the salicylic acid first. This is your COOH, OH over here, plus CH3, CO2, O. In the presence of hydrogen ions, it gives you aspirin, which is this one. OCOCH3. This is acetyl salicylic acid, or your aspirin, plus you have acetic acid, CH3COOH. So these are the two equations which the question asks for. Hope you understood them. Next is question number 24. Do the following conversions in not more than 2 steps. So this is the first conversion and the second conversion. You have to do these conversion in 2 steps at the most. So first one, you have CH3, C triple bond N. In the presence of CH3 NgCl, it gives you CH3C. Here will be CH attached, double bond NMgCl plus 2 molecules of water. This, on further reaction in the presence of hydrogen ions, it will give you, it will be CH3C, CH3 double bond O, plus you will have ammonia and the magnesium chlorine hydroxide. So these are the products formed over here. This is the I have done the conversion in 2 steps. Now the second one, the B part. Here it is. You have the benzoic acid, which is like this, OH. This is your benzoic acid in the presence of sodium hydroxide, calcium oxide. It gives you sodium benzoate. Here you have NaO and double bond O. This is sodium benzoate. Further, in the presence of sodium hydroxide and calcium oxide, it gives you benzene. Right. So we have done, these are the 2 reactions in 2 simple steps. Hope you understood that. Next is question number 25. You have to write down 2 differences between DNA and RNA. This is a pretty easy question. This surely has to come in the exam. So, okay, the DNA, this is deoxy, let's write down, deoxyribonucleic acid and ribonucleic acid. Okay, now this is a double-stranded molecule that has long chain of nucleotides. First point. This is single-stranded molecule which has shorter chain of nucleotides. Okay, this one. And the B part, it is located in the nucleus of the cell in the mitochondria. It is located in nucleus of the cell and in the mitochondria of the cell. And this is located in cytoplasm, nucleus, ribosomes. So these are you were asked for the 2 differences. These are the 2 differences in them. Hope you understood them well. Next is question number 26. This is section C. Now they are going to carry some good marks. Okay, the first one, write the mechanism for the following. This is the reaction and you have to tell the mechanism for the following. And the second part, the same question, why orthonitrophenol is steam volatile while paranitrophenol is not steam volatile. Okay, let's go with we are having a choice also in the question. I'll discuss about this later. First of all, let's go with the A part of the question. So here is A part. You are given the reaction. Let's write it down. That is CH3, CH2OH plus hydrogen. See, over here you are having 2 pairs of electrons over here, and this reacts with the hydrogen ions. This gives you CH3, CH2. Question number 26. Now, this is C section. You are going to get some bigger questions. This is the choice question. You can attend any one of these. Let's start with the first question. It is having again 2 parts. These are the 2 parts, A and B. Let's go with the first one. You have to tell the mechanism for the following reaction. This is the given reaction to you, and you have to tell which mechanism it follows. First thing, it follows SN2 mechanism. Okay, what happens over here is, let's write it down. You have a CH3, CHOH. It has two lone pairs. It reacts with the hydrogen ions at 413 Kelvin. So this gives me what happens. This hydrogen gets attached over here. You have CH3, CH2O positive because hydrogen gets attached. This is the reaction. Okay. Now further, this is your first step. Now further this one, CH3, CH2, OH. Here are two lone pairs. This reacts with CH3, CH2, OH. What happens? This breaks off and it gets attached over here. This will be CH3, CH2, CH2, CH3, hydrogen over here, and this is positively charged plus H2. Okay, now further, this hydrogen also breaks down. This was your second step, and now this will be your third step. So this will give me CH3, CH2O, CH2, CH3 plus hydrogen. This ion will be released and it will come over here. So this completes your mechanism or the reaction. This is the complete mechanism for this reaction following SN2 mechanism. Now the second one, it says why orthonitrophenol is steam volatile while paranitrophenol is not. So the B part, paranitrophenol, it has higher boiling point, has higher boiling point than orthonitrophenol due to intermolecular hydrogen bonds. So they have, what happens? Paranitrophenol has higher boiling point than ortho because they have the intermolecular bonds, whereas orthonitrophenol, this has intramolecular hydrogen bonds. Right? Therefore, the boiling point, in orthonitrophenol, intramolecular hydrogen bonding is present to a very great extent. This is intramolecular and this is intermolecular. And intermolecular forces, they are greater. Therefore, orthonitrophenol is steam volatile because of it is steam volatile because of the low boiling point due to low boiling point. Hope you understood this, right? Now, the second part of the question, what happens when, number one, anisole is treated with CH3Cl anhydrous aluminium chloride. So, okay, let's write down those reactions. I'm clearing the screen. Now, the second part of the question, I'm going to solve that. So, what happens when anisole is treated with CH3Cl anhydrous aluminium chloride? Let's write down the reaction. This is anisole. This is O, CH3. This with reaction CH3Cl in the presence of anhydrous CH3Cl in the presence of anhydrous aluminium chloride and CS2. It gives you OCH3. Here will be CH3 plus and CH3 over here. Now this one is 2-methoxy toluene minor, and this is 4-methoxy toluene. This is major. Right. This reaction is an example of Friedel-Craftsman alkylation. The alkyl groups methyl is introduced at ortho and para positions by the reaction with alkyl halide, that is methyl halide, in the presence of anhydrous aluminum chloride, a Lewis acid, as a catalyst forming methoxytoluene. So this is the complete reaction. Hope you understood that. Let's move to the second part. So the second one is phenol is oxidized with the this chromic acid and chromic acid in the presence of H plus, which is, let's say, given by the sulfuric acid. Okay, so let's write on the B reaction also, the second part also. When phenol is treated with chromic acid, it produces. Let's write it down. So this is your phenol. On reaction with the chromic acid, Na2Cr2O7 in the presence of hydrogen ions, which is given by, let's say, sulfuric acid, it gives you benzoquinone. This one. Um, it it is given by this double bond O and O. This is benzoquinone. So this phenol reaction with the chromic acid, it produces a conjugated diketone, which is benzoquinone. Hope you understood. Now let's move the third part of the question, that CH3 3COH is heated with copper at 573 Kelvin. When a tertiary alcohol like this is a tertiary alcohol, CH3, CH3, CH3OH. When a tertiary alcohol is heated with copper at 573 Kelvin due to the absence of alpha hydrogen atom, dehydration reaction takes place. And here dehydration reaction takes place. And it produces this 2-methylpropene. Not this one. It produces 2-methylpropene, CH3, CH2, and here will be CH3. This is 2-methylpropene. So we have completed all the three reactions which we were asked for. This is your A part and B part. You can attend any one of these, whichever feels you comfortable. So let's move to the next question, number 27. Answer any of the three of the following. The first one is, which isomer of C5H10 gives a simple monochloro compound C5H9HCl in the bright sunlight? See, the molecular formula of C5H10 can have its molecular formula can have a number of structural isomers. This can have a number of structural isomers. However, the fact that the given compound produces a single monochloro derivative when reacted with chlorine in sunlight, this implies that all the hydrogen atoms in the compound, they are equivalent. This is possible only if the compound is, this is possible only if compound is cyclic alkane. Hence, the hydrocarbon is cyclopentane. This one. Let's write down the reaction over here. You have this is like this. C5H10, this is cyclopentane in the presence of chlorine and sunlight. It gives you this C5H9Cl. This is monochloro derivative. So this is the reaction. Let's go with the second one, which what does the second part says you? Arrange the following compounds in increasing order of reactivity towards SN2 reaction. 2 bromopentane, 1 bromopentane, 2 bromo, 2 methyl butane. See, all of these are SN2 reactions. SN2 reaction involve the formation of a transition state. They involve a transition state to be formed. Therefore, the reactivity towards the SN2 reaction depends upon the steric hindrance. Now, due to the presence of 2-methyl group in 2-bromo, 2-methylbutane, it is least reactive towards the SN2 reactions. 2-bromopentane, this is moderately reactive, while as 1-bromopentane, this is, of course, this is the most reactive one. So the correct order becomes, this is the B part, the correct order of the reaction is, first is 2-bromo, 2-methylbutane. This is the least reactive, and this is followed by 2 bromo. This is followed by 2 bromopentane, and the last is 1 bromopentane. So this is the correct sequence in which the reactivity of for the SN2 reaction takes place. Now the C part. Why P dichlorobenzene has a higher melting point? This has higher melting point than those of ortho and meta isomers. See, due to the symmetry of para isomers, which fits into the crystal lattice better than the ortho and better than the ortho and the para isomers, they have the higher melting points and solubility than their ortho and the meta isomers. Okay. Now the D part, you have to identify A and B in the following. So this is the reaction taking place in the presence of magnesium triether. It gives you A. Let's write it down. So here you have, this was the reaction. Magnesium and dry ether, it gives you A. Then further was in the water, it gives B. It's like this. In the presence of water. Let's write it over here. Okay. So from here, you have this is A will be cyclobutyl magnesium bromide, and B will be cyclobutane. Question number 27, answer any three of the following. So you're having 4 questions over here. You can answer any 3 of the following. The first one says, which isomer of C5H10 gives a single monochrome compound of C5H9Cl in the bright sunlight? The hydrocarbon, the one which is asked for, the hydrocarbon is either an alkene or it's cycloalkane. It doesn't react with chlorine in the dark, hence it cannot be an alkene because it doesn't react with the chlorine in the dark. Hence, it is of course a cycloalkane. And according to this, it can be only cyclopentane. Let's see the reaction over here when the cyclopentane, which is given by this is cyclopentane C5H10. This reacts with chlorine in the presence of the sunlight. It gives you this. So this is your here is Cl, monochloro derivative. So the answer to the question is cyclopentane, this one. Hope you understood. Next, the second part of the question. Arrange the following compounds in increasing order of reactivity towards SN2 reaction. You have 2 bromopentane, 1 bromopentane, 2 bromo, 2 methyl butane. See the, I'm going to erase it. Okay. So the SN2 reactions, they involve the formation of a transition state. Therefore, the reactivity towards SN2 depends upon the steric hindrance. Now, due to the presence of 2 methyl groups, that is 2 bromo and 2 methyl, due to the presence of 2 methyl groups in this one, this is least reactive. And if I talk about the 2-bromopentane, this is moderately reactive, whereas 1-bromopentane, this is the most reactive. So you have 1-bromopentane, this is most reactive, followed by 2-bromopentane, followed by the last one, 2-bromo, 2-methyl butane. Right. Hope you understood this. Let's move to the next, the third C part. Why p-dichlorobenzene has higher melting point than those of ortho and the meta isomers. See, due to the symmetry of the para isomers, which fit into the crystal lattice better than the ortho and the para isomers, they have the higher melting points and solubility than their corresponding ortho and the meta isomers. So definitely you got your answer. Hope, right? Now, the last one, you have to identify A and B over here. See, this is your cyclopropyl. This on reaction with magnesium in the presence of dry ether, it gives you organometallic compound A. Here the A will be, see, this will be the reaction. This will be A. Here will be magnesium bromide attached. So this will be cyclobutyl magnesium bromide. And this on further reaction in the presence of water, and on the reaction with the in the presence of and CH3CHO, this gives you this compound. So here you have COH, CH3 and H. This is 1-cyclobutyl ethanol. So this is your compound B and this is your compound A. Right? Hope you understood that. Now let's move to the question number 28. That is the next question of the paper. It says that a first order reaction is 50% complete in 30 minutes at 300 Kelvin and in 10 minutes at 320 Kelvin. You have to calculate the activation energy for the reaction. You have to take the R's value, log 2, log 3 and log 4. These values are given to you. So let's write down first thing. The first order reaction 50% complete in 30 minutes at this much. So 50% complete, that means T of half the time taken. This is equal to half lifetime. This is 30 minutes and over here the temperature 1. This is the time. This is the temperature T1. Let's say this is small t. This is 300 Kelvin and also this completes in 10 minutes. The same one completes in 10 minutes when the temperature is 320 Kelvin. Now the formula log K2 upon K1 is equal to activation energy upon 2.303 R, 1 upon T1 minus 1 upon T2. So this is equal to, wait. Let's fill in the values. You have EA as 0. It's given. Okay, it's not given. EA is not given over here. Right. So log K2, here K will be equal to 0.693. Question number 28, a first order reaction is 50% complete in 30 minutes at 300 Kelvin and in 10 minutes at 320 Kelvin. You have to calculate the activation energy. You are given the value of R, log 2, log 3, log 4 as this. So see, half the reaction completes in the time 30 minutes. And for this, the temperature is 300 Kelvin. And this also completes in 10 minutes when the temperature is 320 Kelvin. Now the formula says log of K2 upon K1 is equal to activation energy upon 2.303 R multiply 1 upon T1 minus 1 upon T2. Also, you know that K is given by 0.693 upon the half lifetime. So this K1 at 300 Kelvin is 0.693 upon 30 per minute and K2 at 320, this is this. Okay, now let's fill in the values, both of these values in this particular equation. You will have log K2 upon K1 is equal to EA upon 2.303 R, 1 upon T1 minus 1 upon T2. Or you have log of 0.693 upon 10, 0.693 upon 30 is equal to activation energy upon this. The temperatures are this much, right? So these things, this will cancel. You will have log 3 is equal to EA upon 2.303 R. Here will be 20 and here will be this. Hope you are clear till here. So next we'll have EA. I'm going to fill the value of log 3, 4.771 into 2.303. R's value 8.3, gas constant 8.314 into 300, and this will be 60. So you will have the value of EA as 43.8 kilojoules. This is the right answer to the question. Hope you understood. Let's move to the next question. Again, a numerical. When 19.5 gram of this FCH2COH, which is having the molar mass as this, is dissolved in 500 grams of water, the depression in freezing point is observed to be 1 degree Celsius. You have to calculate the degree of dissociation for the given molecule. Okay, you have for the water also given to you. Let's write down. First thing, you are having the mass 19.5 gram, and for the given molecule, the molar mass you are given 78 gram per mole. And the change in temperature, for freezing temperature, it is 1 degree Celsius. You are having Kf as 1.86 kilogram, Kelvin kilogram per mole. Okay, so all right. You know one thing, that delta Tf is equal to Kf into molality into I. So you have this molality is equal to moles of solute divided by kg of solvent. What is the moles of solute? This is the given mass upon the molar mass, and the kg of solvent, this is equal to 500, like it's given 500 gram, right? I'll do the conversion. 500 upon 1000. So on solving this, you will have 0.1 m as the molality, and I is change in the temperature, freezing temperature, Kf into molality. Let's fill in all the given values. This is equal to 1, Kf is 1.86, and this is equal to 0.5. So your I comes out to be 1.07. Okay, now for the given molecule, for CH2FCOOH, you have I as 1 plus alpha. So alpha is equal to I minus 1. This is 0.07. Right, hope you understood that. So this is the answer to the question. Let's move to the next question now. Question number 30. You have to draw the geometrical isomers for the given ion. Which geometrical isomer of the given ion is not optically active and why? You have to, the second part for the question. Okay, I'll talk about the second part later on. First of all, go with the first one. So you have to draw the geometrical isomers for the given ion. Which geometrical isomer is not optical active and why? First of all, this is the given one, COEN2Cl2 positive. Fine. So the two given geometrical isomers will be something like this. You are having cobalt over here, Cl, Cl. Here will be like this, like this. So this is the first one. This is the cis form of it. And this is for the plus. And let's go for the second one. Cobalt over here, like this, En, En. Like this. So this is the second one. This is the transform. Trans isomer of the given ion. Okay, this is first of all positive charge. Yes. Now the trans isomer of the given ion is not optically active because of the plane of the symmetry. So trans isomer is not optically active due to the plane of symmetry it is having. Right? See, it is having the plane of symmetry. If you look at this one, this is symmetrical. So this is the first part. Now the second one, write the hybridization and magnetic behavior of the given ion. You are given the atomic number of cobalt is 27. Electronic configuration, first of all, let's write down for the given ion. Electronic configuration for the given, you have COF6 3 minus. For this is cobalt will be it's argon. First of all, you have argon, which is having the atomic number 18, then 4s2, 3d7, because cobalt is having the atomic number as 27. So this is the electronic configuration for the cobalt. And wait, just a minute. It is okay. Now you're having oxidation state for COF6 3 minus will be given by x plus 6 into minus 1 is equal to minus 3. This gives me x is equal to minus 3 plus 6, or x will be equal to plus 3. So this is the answer what we were looking for. 8. Okay, we have to write the hybridization and magnetic behavior of it. See, the hybridization of cobalt atom in this one will be hybridization of cobalt atom in COF63 minus, this will be sp3d2, because over here you're having sp3d2. Yes, this will be the one. And the magnetic behavior is paramagnetic due to the presence of 4 unpaired electrons. And magnetic behavior is paramagnetic due to the presence of 4 unpaired electrons. Hope you understood that. Now let's move to the next question. Question number 31. Now this is section D. There are going to be some high questions, like bigger questions will be asked, which are carrying good marks, higher marks. Now these are the following questions based on this. The following questions are case-based questions. You have to read the passage carefully and answer the question that follows. The carbon-oxygen double bond is polarized in aldehydes and ketones due to higher electronegativity of the oxygen relative to the carbon. Therefore, they undergo nucleophilic addition reactions with a number of nucleophiles such as HCN, NaHSO3, alcohols, ammonia derivatives, and Grignard reactants. Aldehydes are easily oxidized by mild oxidizing agents as compared to ketones. The carbonyl group of the carboxylic acid does not give reactions of the aldehydes and ketones. Carboxylic acids are considerably more acidic than alcohols and most of the simple phenols. You have to answer the following. The very first one says you write the name of the product when an aldehyde reacts with excess alcohol in the presence of dry HCl. When an aldehyde reacts with the excess of alcohol in the presence of dry HCl, alkoxy alcohol intermediate known as hemiesters will be formed. In this case, I'm answering the first one. In that case, oxy alcohol intermediate, which is known as hemi acetals, will be formed, which further react with one more molecule, react with one more molecule of alcohol to give gem dioxy compound, dioxy compound, which is known as acetal. So this was the answer to your first question. Now the second, why carboxylic acid is stronger acid than phenol? The conjugate base of the carboxylic acid is a carboxylate ion. For the second one, conjugate base of carboxylic acid is carboxylate ion. It is stabilized by two equivalent resonance structures in which the negative charge is at the more electronegative oxygen ion. The conjugate base of the phenol is a phenoxide ion of phenol is phenoxide ion, which has non-equivalent resonance structures in which the negative charge is at the least electronegative carbon atom. Therefore, resonance in the phenoxide ion is not as important as it is in the carboxylate ion. Hence, carboxylic acids are more acidic in comparison to the phenols. Okay, hope you got that. So let's move to the third part. Arrange the following compounds in increasing order of their reactivity towards CH3 and GBr. This is 1, this is 2, and 3. So you have to arrange them. Okay. This is a 1-mark question, so I'm going to directly write about their reactivity. This is the third part, I think. C, first part. Okay. This is C, first part. The first one, you have CH3, 3C, CH3. Double bond O. This is less than CH3, CH3, double bond O, less than CH3, CHO. Now, the last one, you have to write a chemical test to distinguish between propanol and propanone. We can use the ideoform test to distinguish between both of them, as aldehyde group shows this test, whereas ketones do not. So the second part, I will use this test because aldehydes shows this test and ketones do not. So we have solved all the questions for this first one. And now this question is in choice. You are having, or you can write down the main product for the following reaction. So this is the given reaction. You can write down the main product of it. Hope you are clear with this one and all the questions. Let's go with the second option for the question. That is this reaction. You have to write down the main product over here. So first of all, you are having this reactant OCHO in the presence of AgNH3 plus it gives you not the ring. So here will be double bond O, here will be COO negative and silver. It precipitates down. So next, the second one, this was the first one, the second one. Here you have this ring, then you have CHO, H2NCONH, NH2. It gives me CHN, NHCO, NH2 plus water. So these are the two complete reactions. Hope you understood them well. Let's go to the next question, number 32. Question number 32. Now, this section, the following questions are based on case studies, and you have to read the passage carefully and answer them. Carbohydrates are optically active polyhydroxyaldehydes and ketones. They are called steroids. All these carbohydrates, which reduce failing solution and tolerance reagent, are referred to as reducing sugars. Glucose, the most important source of energy for mammals, is obtained by the hydrolysis of the starch. Vitamins are assessed are here will be necessary food factors required in the diet. Proteins are the polymers of alpha amino acids and perform various structural and dynamic functions in the organisms. Deficiency of the vitamins leads to many diseases. You have to answer the following questions based on this. The very first one, pentaacetate of glucose does not react with the hydroxylamine, which what does it indicate? See, the pentaacetate of D-glucose does not react with hydro. Let's write down. Okay, it does not react with the hydroxylamine, which is this NH2OH. This is because of the absence of aldehyde group, because of the absence of aldehyde group and an open chain structure. So next one, the B part, why cannot vitamin C be stored in our body? Since vitamin C is soluble in water, it dissolves in water and is excreted out from the body via the urine. As a result, vitamin C cannot be stored in the body. Third one, you have to define the following as related to proteins, peptide linkage. Peptide linkage, which is given by peptide linkage, which is given by this, is a peptide bond which is formed between two amino acids. Is a peptide bond which is formed between two amino acids. So this is the first one. We have defined this one, and the next one is denaturation. Okay, the protein with the unique. What is denaturation? This is the second part for the C. Protein with unique 3D structure and biological activity is called a native protein. When a protein in its native form, it is subjected to the physical change like temperature or chemical change in the pH, the hydrogen bonds will be disturbed. Globulars unfold and helix get uncoiled and protein loses its biological activity. This is called denaturation. Hope you understood that. So the first part of the question is done. Now this is in the choice. You are having or. Let's go with the second part or the second option of the question. It says you have to define the following as related to carbohydrates. First ones are anomers. Anomers, they are apimers of cyclic monosaccharides or glycosides that differ in the configuration of C1 if they are all aldoses, or in the configuration of if they are in the configuration of aldoses, or in the C2 if they are ketosis. Right. So anomeric carbon for the anomeric center refers to the epimeric carbon in the anomers. The second part, glycosidic linkage. The two monosaccharides are joined together by an oxide linkage. Oxide linkage formed by the loss of a water molecule. The linkage of the two monosaccharide units via an oxygen atom. This is called your glycosidic linkage. Hope you understood that. So let's move to the next question, number 33. Now, again, a choice is given in this question. This is the first part. This is the second part. First of all, let's go with the first part of the question. Right. So first one says, account for the following. E naught value for Mn3 plus, Mn2 plus couple is much more positive than the chromium 3 plus and Cr2 plus. Okay. First of all, you are having Mn plus 2. This is given by argon, which is having the atomic number 18, 3d5, and Mn plus 3. This is argon 18, 3d4. Due to the presence of half-filled 3d orbital Mn3 plus this is half-filled, so this is more stable. While if I talk about Cr2 plus, this is Ar18 3d4 and Cr plus 3 Ar18, there will be 3d3. Due to the presence of half-filled Tg, sorry, due to the half-filled 2Tg orbital, this one is less stable. Therefore, this Mn plus 3, Mn plus 2, they have higher EO in comparison to Cr2 plus and Cr plus 3. Hope you got that. Now the second part, it says Sc3 plus is colorless, whereas Ti3 plus is colored in an aqueous solution. Okay, let's go for this. The electronic configuration is argon 18 and for Ti plus 3, here is argon 18, 3d1. Now, due to the presence of one unpaired electron over here in the Ti plus 3, it is colored due to one unpaired electron over here. So this is colored in the aqueous solution, whereas this one is colorless. Hope you got that. Now the third part of the question, it says actinoids show wide range of oxidation states. Now in the actinoids, due to the presence of one unpaired electron in Ti plus 3, sorry, this one is actinoids, right? Okay, actinoids, now due to the presence of small energy, due to the presence of small energy gap between 5f, 60 and 70 orbitals, actinoids show wide range of oxidation state. Now, the next, last one, write the chemical equation for the preparation of KMnO4 from MnO2. So you have to write down the equation, chemical, let's write it down. This is the fourth part of the question. On a large scale, KMnO4, potassium permanganate, is obtained by pyrolusite ore, that is MnO2. It is done by MnO2 plus potassium hydroxide, oxygen, it gives you K2, MnO4 plus water. Now let's do the balancing. Here will be, okay, here will be 2. This will be 4, 2, here will be 2 and 2. This is green in color. All right. So this is K2MnO4. Now K2MnO4 undergoes this proportionate reaction in a neutral or acidic medium to give you permanganate, potassium permanganate. Now this, let's write it over here. Potassium K2MnO4 in the presence of hydrochloric acid like the neutral or the acidic medium, it gives you KMnO4 plus MnO2, water, and potassium chloride. Okay, so let's do the balancing. Here will be 3, here will be 4 molecules of this. It gives you 2 molecules of this. So 1, here will be 2 and 4. So this is the complete reaction that was asked for. That's it. Now, this was the first part Or account for the following: transition metals from alloys. Okay, first of all, account for the following. I'm going to erase the screen. Now I'm going to solve this part of the question. That is the choice part again. Okay. Now, account for the following: transition metals from form alloys. Transition metals have almost similar atomic sizes. They can mutually substitute their sizes in the crystal lattices and can form alloys. Like, for example, you can say brass, bronze, steel, etc. Now, the next one, Ce4 plus, this was for this, okay. Ce4 plus is a strong oxidizing agent. Ce plus 4 gets reverted to plus 3 oxidation state in the aqueous medium. Aqueous state in oxidation medium, oh, sorry, in the aqueous medium. Therefore, it's a good oxidizing agent. The next one. Write one similarity and one difference between chemistry of lanthanoids and actinoids. You have to write down the one similarity and one difference between them. First of all, let's talk about the similarity. Both of them exhibit similarity. Both of them exhibit irregularity, irregularity in their electronic configuration. Both are stable in their plus. Both are stable in their plus 3. Both are stable in their plus 3 oxidation state. And let's talk about the difference. Actinoids are mostly radioactive. They are radioactive, and lanthanoids are not. All right. Now that you have to complete this ionic equation. Let's write it down. You have Cr2O72 minus plus 2OH negative. This gives you CrO42 negative plus water. Let's do the balancing. This is right. So we have completed the reaction. All the both the questions or the parts are done for the 33rd question. Now let's move to the question number 34. You have to give the reasons for the following. The first one, again, a choice is given in the question. So I think all the questions in this section, they are gonna have the choice. Let's go with the first one. This says, this is the first question till here. Till here. Okay. Now the first part, aniline on nitration gives good amount of M-nitroaniline through NH2 group is OP, directing in electrophilic substitution reactions. Direct nitration of the aniline yields oxidation products in addition to the nitro derivatives. Moreover, in the strongly acidic medium, aniline is protonated to form the aniline Ra. So this is the number 34. You have to give the reasons for the following. Again, you're having a choice in this question. So you have to give a reason for this following, like 1, 2, 3, and then this one. Okay. So number of questions will be asked. They are very small questions. Let's pay attention to the very first question. You have to give the reason for aniline on nitration gives good amount of M-nitroaniline through NH2 group is OP, directing in electrophilic substitution reactions. Direct nitration of the aniline yields oxidation products in addition to the nitro derivatives. Moreover, in the strong acidic medium, aniline is protonated to form aniline ion, which is meta-directing. That's why, because besides the ortho and the para derivatives, significant of meta derivative is also formed. Okay. So this is ortho and para derivatives. You have significant of meta derivatives also. Let's go with the second question, that CH3 2NH is more basic than CH3 3N in the aqueous solution. See, the secondary amines have comparatively less steric hindrance than the tertiary amines. Therefore, CH3 2NH is more basic than CH3N in the aqueous solution. Right. Now the third one, it says Ammonolysis of alkyl halides is a not good method to prepare pure imaginary amines. Pure primary amines. The third part, this one. See, ammonolysis has the disadvantage of yielding a mixture of primary, secondary, and tertiary amines, and also a quaternary ammonium salt, due to which it is not good method to prepare pure primary amines. All right. So now let's go with the second question, second part. You have to write the reaction involved in carbyl amine test. So let's write down that reaction now. First thing. Okay. What is it? Carbyl amine test. Write the reaction involved in the following. So first of all, I'll have the primary amine R NH2 plus chloroform 3KOH. When heated, it gives you RNC. This is carbyl amine plus potassium chloride plus water. This will be 3. This will be 3. This will be 3. Yes, it's balanced. Okay. So the second part, the Gabriel pethalamide synthesis. Let's go for this one also. This was your second part for it. First of all, you have the pethalamide. This is your benzene ring. COO. Here will be NH. In the presence of potassium hydroxide, this gives you CO, and here is N, and H will be removed over here and K will come at its place. You will have K plus over here. Now this further, on reaction with the alkyl halide, it gives you this CO, and now this R will be replacing this, X will be replacing by this K, and R will attach over here. This is N alkyl ethylamide. Now, this further on reaction with the aqueous sodium hydroxide, it will give me so here will be CO, CO, ONA, ONA plus RNH2. This is primary amine. So this is the complete reaction for the B part. Okay. Now, hope you understood. Now I'm going to the OR part. That is the second question, or the one which is in choice. Let's go for this. What is this reaction? This is, let's write it. C6H5N2Cl. In the presence of CuCN, it okay. This gives me C6H5Cn. Further, with water and hydrogen ions, this gives me C6H5COOH. Further, in the presence of ammonia, this is your B, this is your A. And further, in the presence of ammonia, this gives me C6H5COONH4. Further, on heating, and water will be liberated. This will be C6H5CONH2. This is your C product. All right. So this is your A, this is your B, and this is your C product. Hope you're clear with this. Let's check it once again. Yes. Right. Now let's go. This is the first reaction. Now let's complete the second one. Let's make it over here. You have aniline over here, aniline. This is sorry, this is not aniline. This will be the aniline. This will be formed over here. In the presence of iron and hydrochloric acid, this gives you, here will be NH2. This is your aniline, right? And then further, this NaNO3 plus HCl 273 Kelvin. This gives you this product, N2Cl. So because this Cl will be attached over here, and this one is benzene diazonium chloride. This is your P. This is your A product, right? Further, in the presence of C2H5OH, it gives you benzoic acid. This is your C product. So all the three products, they are clear to you, right? Hope you understood them. Now, the next one, why aniline does not undergo Friedel-Crafts reaction. Okay, the B part to it. Now, it is due to the fact that aluminium chloride, being electron deficient, acts as a Lewis base and attacks on the lone pair of nitrogen present in aniline to form insoluble complex which precipitates out and doesn't proceed. All right, so that is the reason why aniline does not undergo the Friedel-Crafts reaction. Hope you are clear with this. Now, the last one, you have to arrange them in the increasing order of their boiling points. These are the three ones. You have to arrange them. So let's write down. You have C2H5OH, C2H5NH, and C2H53N. Their right order of the boiling points is C2H5NH2, then C2H5OH, C2H53N. This is the right order of their boiling points, because the boiling point of this is the highest, they followed by this, followed by this. Hope you're clear with this. Let's move to the last question of this chemistry section for the paper. It says conductivity of 2 into 10 power minus 3 m methanoic acid is this much. You have to calculate its molar conductivity and the degree of dissociation. If this molar conductivity for the infinite dilution for the methanoic acid is given by this. This is the A part. First of all, let's solve this. So you are given the conductivity over here as 2 into, conductivity of this much and methanoic acid. The conductivity is 8 into 10 power minus 5 s per centimeter, and molarity, which is given by m, is this much. So using the formula, molar conductivity is K into 1000 upon C, degree of dissociation. Alpha is given by molar conductivity divided by the molar conductivity for the infinite dilution. So this is equal to, this one is K into 1000 upon C, and followed by dissociation for the infinite dilution. This is, infinite dilution is given as 404. It's right up 404. Now filling in all the values, I was given K is equal to 8 into 10 power minus 5,000. C's value is 2 into 10 power minus 3 into 1 upon this. So this cancels at 4, this cancels at 101, and this cancels at 10 power minus 2. this will be equal to 10 upon 101, which approximately I'll take it as 10 upon 100 only. Approximately, that will be 0.1. So that's it. We want the degree of dissociation. It came out to be 0.1. Next, you have to calculate the delta G naught and log Kc for the given reaction at 298 Kelvin. This is the given reaction. You are given that E naught Ni2 plus, and Ni is given by upon Ni is this, and E naught Ag plus upon Ag is given by this. Also, when farad is equal to this much. Let's write it down. So you have E naught for the cell as this value. Now in the question you are given that this is equal to 0.8 and this is minus 0.25. This is equal to 0.80 plus 0.25. This is equal to 1.05 volt. Also delta G naught. This is equal to minus N F E naught cell. This is minus 2. F value is 96500. And if this we just calculated, this is 1.05. On solving, you will have this as minus 2 into 10 power 5 joules. So delta G naught is equal to 2.303 RT log Kc also. This is the value we already have solved this. So this is equal to minus 2 into 10 raised to power 5 divided by 2.303 R gas constant 8.314 into temperature 298. It's given. This is equal to log Kc. So log Kc is equal to 35.52. That gives you the answer to the question. That is what we needed to find out, these two values. And students, with that, we have completed all the 35 questions for chemistry for the outside Delhi 2023 set 1 paper. Hope you understood them well. And don't forget to visit our website www.examsnet.com. Here you will find so many entrance exam question papers along with the detailed PDF solutions. Also, you may download our app. The link is available in the description box. A very best of luck for your exams. Keep shining, keep rising high. That's all for this paper. Bye. Terms of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice your entrance exam question papers, all of them, and the link is available in the description box. You must download our. Students, today we'll be solving CBSE class 12 chemistry 2023 outside Delhi set 2. We already have solved set 1 and this set is in continuation with the set 1. You can watch our previous video for seeing all the set 1 questions. So I'll be starting with the set 2 questions in this particular video. A very best of luck. Here we go with the very first question for this paper. Which of the following belongs to the class of vinyl halides? These are the options given to you. Vinyl halides, compounds which are having the formula CH2, double bond CHX, where X is halide, they are considered as vinyl halides. And looking at that, this is the right answer to the question because you have a double bond at the first place over here. And this is halide, this is the bromide attached over here. So this is your vinyl halide. And the right answer to the question is option B, sorry. Hope you got that. Next is question number 2. What is the secondary valency of cobalt in the given ion? Okay, let's write it down. You have this ion. The coordination number is another name for the secondary valency. Coordination number is another name for this. Therefore, the secondary valency for the given one is. What is the secondary valency of cobalt in the given ion? Secondary valency, this is also called a coordination number. And this is defined as number of coordinate bonds in the coordinate sphere, in the coordination sphere of the central metal atom, which is cobalt in this case, with the ligands En and Cl. In the given complex, cobalt binds with two bidentate ligands. En, so this is 2 into 2, 4, and 2 monodentate ligand, that is Cl. So this is 2, which gives you a total of 6 coordination number. So the coordination number will be 6. That makes option A to be the right answer. Hope you understood this. Now let's move to the next question, number 3. Question number 3, when benzene diazonium chloride. Question number 3, when benzene diazonium chloride reacts with phenol, it forms a dye. What is this reaction called? This reaction is called a coupling reaction. It is joining of two chemical species with acid of a metal catalyst. Benzene diazonium chloride reacts with the phenol. It reacts with phenol molecule as it is a parasite position, as its para position is coupled with the diazonium salt to form P hydroxy azobenzene. This type of reaction is called the coupling reaction. So C is the right answer. Hope you understood this. Let's move to the next question, number 4. Proteins are polymers of. They are the polymers of amino acids. Amino acids polymerize to form protein having peptide bond. Thus, they are the polymers of the amino acids. Option B is the right answer. Next is question number 5. Retention of configuration is observed in SN1 reaction, SN2, neither of them, or in both of them. The right answer to the question is option A, SN1 reaction. In these reactions, both retended as well as inverted products are formed. Whereas in the SN2 reaction, only inverted products are formed. That makes the first option to be the correct answer. Hope you understood this. Let's move to the next question, number 6. An azeotropic mixture of two liquids will have the same boiling point, or will have a boiling point lower than either of the two liquids when it shows a negative deviation from Raoult's law, forms an ideal solution, shows a positive deviation from Raoult's law, or it's saturated. The right answer to the question is it shows a positive deviation from the Raoult's law. Azeotropic mixture of two liquids will have a boiling point lower than either of the two liquids when it shows a positive deviation from the Raoult's law. Okay. See, when a solution deviates from the Raoult's law, the intermolecular forces between the solute and solvent, intermolecular forces between the solute and solvent are weaker than the interactions between the solute and the solvent. The solution's total vapor pressure is greater than the total vapor pressure of the the solution's total vapor pressure is greater than the total vapor pressure of the ideal solution. Furthermore, the vapor pressure of each component is greater than predicted by the Raoult's law. As a result, the azeotropic mixture of two liquids boils at a lower temperature than either of them individually. That makes C option to be the correct answer. Hope you got that. Let's move to the next question, number 7. Which of the following does not give Cannizzaro reaction? Okay. given options according to this, the second one, CH3 to CHCHO, this aldehyde doesn't give you the Cannizzaro reaction. See, aldehydes which do not have alpha hydrogen, aldehydes that do not have alpha hydrogen atom undergo self oxidation and reduction, which is disproportionization. This reaction on heating will, with concentrated alkyl, such reactions, they are known as the Cannizzaro reactions, and this is not exhibited in this aldehyde because it doesn't have the alpha hydrogen. That makes option B to be the right answer. Hope you understood this. Next is the question number 8. Aldehydes and ketones react with hydroxylamine to form which of these following options? Uh, the right option to the answer is oxime, option D. Aldehydes and ketones undergo nucleophilic addition reaction when allied to react with hydroxylamine, forming oximes. So you have D option as the right answer. Next is the question number 9. Which among the following metals of 3D series has the lowest melting point? I think I forgot. Okay, no, fine. So, okay, fine. Question number 9. Which among the following metals of 3D series have the lowest melting point? This is iron, manganese, zinc, or copper. Due to the absence of the unpaired electrons in the zinc, metallic bonds are very weak in it. Therefore, zinc has the lowest melting point because of absence of unpaired electrons. This has the lowest melting point in it. So, hope you understood this. You have C option as the right answer. Next is question number 10. You have assertion reason. Assertion A says that the elevation in boiling point is a colligative property. Reason says the lowering of the vapor pressure of the solution causes elevation in the boiling point. The right answer to the question for that, see, first of all, the reason. Assertion, elevation in boiling point is a colligative property. That's right. And the reason says the lowering of vapor pressure of the solution causes elevation in the boiling point. Actually, both of them are correct. Both assertion and the reason are true. And reason is the correct explanation of the assertion. The lowering of the vapor pressure of the solution causes elevation in the boiling point. Therefore, elevation in boiling point is a colligative property. That's true. We have first option as the right answer. Hope you got that. Next is question number 11. It says, assertion says chlorobenzene is resistant to electrophilic substitution reaction. Reason is CCl bond of chlorobenzene acquires partial double bond characters due to resonance. If I read this one, chlorobenzene is resistant to electrophilic substitution reaction. This assertion is incorrect. This is wrong. Because of the resonance of chlorobenzene acquires a partial double bond characters, which makes it highly reactive towards the electrophilic substitution reactions. Question number 11, assertion says chlorobenzene is resistant to electrophilic substitution reaction, and the reason says CCl bond in chlorobenzene acquires partial double bond characters due to resonance. If I look at the reason, because of the resonance, chlorobenzene acquires partial double bond characters, which makes it highly reactive towards the electrophilic substitution reaction. So this is wrong. It is not resistant. It is highly reactive. So that means the reason is correct, but the assertion is false. That makes the D option to be the correct answer. Hope you understood. Next is the question number 12. It says transition metals have high enthalpy of atomization, and the greater the number of unpaired electrons in transition metals results in weak metallic bonding. Actually, both of them are correct because of the large number of unpaired electrons in their atoms. When so many electrons are unpaired in the atoms, they have stronger interatomic interaction and hence stronger bonding between the atoms, resulting in higher enthalpies of atomization. So both of them are correct. That is first option. This is the right answer to the question. Hope you understood that. Let's move to the next question. Question number 13, section B. Now you don't have a choice. You have to write down the answers as it is. What is the difference between a nucleoside and nucleotide? Okay, so you have to tell the difference between them. The main distinction is in their molecular composition. With nucleosides containing only sugar and a base, nucleosides contain only sugar and a base, and nucleotides, they contain sugar, base, and a phosphate group. A nucleotide is what occurs before contain. So this is what occur before RNA and DNA, while nucleosides occur before nucleotide itself. So these are the main differences between them. Next one, the B part says, what products would be formed when a nucleotide from DNA containing thymine is hydrolyzed? When a nucleotide from the DNA containing thymine is hydrolyzed, thymine, let's write it down, thymine beta T2 deoxyribosome and phosphoric acid are obtained as the products. Hope you got that. Then with that, let's move to the last question of the paper. What is the chemical equation involved in Kolbe's reaction? In the first type of reaction, that is a Kolbe's reaction, what is that? This is addition reaction, and an addition reaction in which phenol is treated with sodium hydroxide and phenoxide ion is generated. The phenoxide ion generated is more reactive than phenol towards electrophilic aromatic substitution reaction. Let's see this thing around using this reaction. You have the phenol over here. Reaction with sodium hydroxide. This is phenol, and here you will have sodium phenoxide. Phenoxide ion will be generated, and plus carbon dioxide, this at 400 Kelvin, 427 atmospheres. This gives you sodium salicylate. This is given by OH over here, COONA, and again in the presence of dilute hydrochloric acid, and sodium chloride will be liberated at this case. So here you will have this OH and COOH. This is 2-hydroxybenzoic acid, which is also known as salicylic acid. So this is your Kolbe's reaction. Hope you understood that. Let's move to the second one, which is your Williamson's synthesis. What is that Williamson synthesis? This is a general method for the synthesis of ether. This involves nucleophilic displacement of a halide ion or other good leaving group by an alkoxide ion. Let's see this binary reaction again. So you have CH3, 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 ONA. Now this one reaction CH3Br. What will happen? This lone pairs. Now this will move at this molecule. You will have CH3OC, CH3, 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 like this. And plus, of course, because the sodium will go with the mean, sodium bromide will be released. So this is your Williams synthesis in which an ether is produced. Synthesis of an ether. This involves the nucleophilic displacement of an halide over here by a good leaving probe or by an alkoxide ion. So with that, we have completed all the questions, all the 14 questions for this set of paper, Delhi Outside Set 2 paper. Hope you understood them well. And don't forget to visit our website, www.examsnet.com. Here you will find all the entrance exam question papers along with the detailed PDF solutions. And don't forget to visit our website, download our app. The link is available in the description box. So students, keep shining, keep rising high. That's all for this paper. Bye. Chunks of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This is a great place for you to practice your entrance exam question papers because you have so many entrance exam question papers as well as their detailed PDF solutions over there. For a better preparation, you must download our app. The link is available in the description box. Students, today we'll be solving CBSE Class 12 Chemistry outside Delhi, Set 3. Set 3 paper, I have already uploaded set 1 and set 2 papers. You can watch them. And this paper, this set 3 is in continuation from that only. All right. So very best of luck. Here we start with the question number 1 for the given paper. It says auto-oxidation of chloroform in air and sunlight produces a poisonous gas, which is known as which of these? When chloroform, let's go, when chloroform, that is HCl3, it reacts with air and sunlight, it produces a toxic gas that is phosgene gas. This is COCl2 along with the hydrochloric acid. Let's see the chemical reaction of it. You have CHCl3. This is chloroform on reaction with oxygen present in the air. In the presence of the sunlight, it gives you phosgene gas. Along with the hydrochloric acid. Let's do the balancing also. Here will be 2, 2, and 2. So now it's balanced. So the give answer to the question option C. Hope you got that. Let's move to the next question number 2. Which of the following ligands is an ambidentate ligand? Ligand which is having two different donor atoms, and either of the two ligands in the complex. This is called the ambidentate ligand. For example, nitrogen dioxide, CN, etc. So out of these options, you have B option as the right answer. Hope you understood that. The ion over here can bind to the central atom either through the nitrogen or through the oxygen, one of the oxygen atoms, but not again at the same time. This is your nitro and this one becomes your nitrito. Right. Now, hope you understood. We have option B as the right answer. Let's move to the next. That is question number 3. Among the following, which is the shortest value of pKb? Okay. So these are the given options and you have to find out the shortest value. See, this value is inversely proportional to the basic strength. No. In the nitrogen dioxide, due to the presence of electron withdrawing, this one, the option over here, this has the electron withdrawing capacity, or this is NO2, which is an electron withdrawing group. So the electron density decreases on the nitrogen atom. Electron density decreases. If it decreases, therefore this one, that is phenyl methane amine, is the least basic one. This phenyl methane amine is the least basic one. Why? Because it is having NO2 group. And this value is inversely proportional to 1 upon the basic strength. So the basic strength of it decreases. Phenylmethanamine is least basic, so it will have the highest value of this. We have option D as the correct answer. Hope you understood this. Next is question number 4. When D-glucose reacts with HI, it forms which of these following? On prolonged heating with HI, um, let's see which D-glucose reacts with HI. Let's write down the reaction first of all to understand. This is CHOCH4. Here you have CH2OH. This is your D-glucose. This reacts with hydrogen iodide unheated. You get CH3, CH2, 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 CH3. This is N-hexane. So N-hexane is formed. On prolonged heating with the hydrogen iodide, it forms N-hexane, suggesting that all the 6 carbon atoms are linked by a straight chain. So we have B option as the correct answer. Hope you understood that. Next is the question number 5. Inversion of configuration occurs in SN2 reaction, SN1, neither of them, or in both of them. The right answer is option D, in both of them. In SN1 reactions, both retented as well as inverted products are formed, while in SN, let's write down, in this one, both retented and inverted products are formed. While in the SN2, only inverted products are formed. So inversion of configuration occurs in both of them. That makes D option to be the correct answer. Hope you understood that. Next is question number 6. Solubility of gas in liquid decreases with increase in pressure, temperature, volume, or number of solute molecules. Solubility of gas in liquid decreases with increase in the temperature. When the temperature rises, when temperature rises, then kinetic energy will increase. The increased kinetic energy causes more motion in gas molecules, which breaks intermolecular bonds and allows the molecules to escape from the solution. As a result, the temperature rises, the gas solubility decreases. So we have B as the right answer. Hope you got that. Next is question number 7. Which of the following relations is correct? These are the 4 relations given to you. Let's check out which is the right one. So, okay. The R represents your resistance over here. So the inverse of resistance R is called inverse of resistance R is conductance, which is given by the G. So you have G is equal to inversely proportional to 1 upon R, or this is given by G is given by A upon rho into L. So this is K into A upon L. Question number 7, which of the following relations is incorrect? You have resistance, you have K, L, A. Okay. First thing that I would like to say, you have resistance and conductance over here. And you know resistance inverse is conductance, which is given by G. So you have G is equal to 1 upon R. You know R is equal to rho into L upon A. Rho is the resistivity. L is the length. A is the area. And you have this as conductance and this is resistance. So G can be written as 1 upon rho A, R, sorry. 1 upon R, I can write it as A upon rho into L. Or 1 upon rho, I will write it as K into A upon L, where K I'm taking as, let's say the K is equal to 1 upon rho. So the very first one, we know we have over here R is equal to Let's write it over here. A option, R is equal to 1 upon K, L upon A, that is area. Small a, capital A, that's okay. Like they have taken small a and I have taken the capital A for the same. No issues. And 1 upon K, this is equal to rho L upon A. So this is right. This is not incorrect. This is the correct one. G is equal to K A upon L. That is also right. G is equal to K L upon A. This is wrong. And even the fourth one is right. So which is the incorrect option? We have option C as the incorrect option. Hope you got that. Next is question number 8. The reagent that can be used to distinguish between acetophenone and benzophenone is which of the following? The right answer is iodine and NaOH, sodium hydroxide. The iodine and sodium hydroxide tests are used to distinguish between the two. In the preceding test, when the iodine molecules react with acetophenone, iodine molecules react with acetophenone. They combine with the methyl groups to form methyl iodide. The formation of methyl iodide results in the formation of yellow precipitate, indicating that the compound is acetophenone. Question number 8, the reagent that can be used to distinguish between acetophenone and benzophenone is. These options are given to you, and out of these options, iodine and sodium hydroxide, this is the right answer. The test with iodine and sodium hydroxide are used to distinguish between the two. See what happens when iodine molecules react with acetophenone. They give you methyl groups to form methyl iodide. Now, this is in the form of yellow precipitates. Whereas when iodine and sodium hydroxide, they react with benzophenone, no precipitates are formed. This reaction doesn't occur because benzophenone has a ring which prevents this precipitation. Has a ring that prevents precipitation. So you have D option as the correct answer. Hope you understood this. Next is question number 9. Which of the following compounds will undergo self-condensation in the presence of dilute sodium hydroxide solution? The right answer among the following is option B. Aldehydes and ketones having at least one alpha hydrogen undergo a reaction in the presence of dilute alkali as a catalyst to form B-hydroxyaldehydes. That's right. Aldehydes and ketones having, this question was discussed previously also, one hydrogen atom, one alpha having alpha hydrogen atom undergo a reaction in the presence of dilute alkali as a catalyst to form beta hydroxyaldehydes aldols and beta hydroxyketones ketones respectively. Now this is called the aldol reaction. CH3 CH2 CHO due to the presence of alpha hydrogen shows aldol reaction. Right. So you have B option as the right answer. Hope you understood that. Next is question number 10. Which of the following transition metals shows +1, +2 oxidation state? The right answer to the question is Cu, that is copper. Copper exhibits both +1 and +2 states. They are very stable states. This exhibits +1 state, oxidation state very frequently because the electronic configuration for Cu plus, that is cuprous, is given by argon, which is having atomic number as 18, 3d10. The completely filled d orbit. This is having 10 electrons. This is completely filled, makes it highly stable. And if I talk about Cu plus 2, this is even a very stable oxidation state, and this is cupric. That's cuprous. This is because the d orbital will be half filled in the plus 2 oxidation state that results in high negative enthalpy of hydration that makes it more stable in forming the aqueous solutions. So you have both the plus 1 and plus 2 states for the copper. That makes copper to be the right answer to the question. Hope you got that. Next is question number 11. The formula for the complex iron 3 hexacyanide ferrate 2 is given by. So I'll start from here. Hexacyanide. That means you have 6 cyanide over here, CN6. Ferrate, that means you have ferrous, that is iron over here. So hexacyanidoferrate 2, that means the valency of iron over here is 2, and the CN6 will have the valency of, this will be total of like -6. This will be this, and you have the 6 over here, so plus 2 minus 6, this will give me -4. That means here you have iron, because you have iron 3, the valence is 3, here will be 3, and this 4 will come at this place. So this is the right formula. That makes the option to be the right answer. Hope you got that. Next is question number 12. The enthalpy of mixing is equal to 0 for an ideal gas. The reason says for an ideal gas solution, the interaction between the solute and solvent molecules is stronger than the interactions between solute and solvent molecules. Actually, both of them are correct, and the reason is the right explanation for the assertion. For an ideal gas solution, the interaction between the solute and solvent molecules is stronger than the interactions between both of them, solute, solute, or solvent, solute, solute, or solvent molecules. The enthalpy of mixing and volume of mixing both are 0 for an ideal gas. This is due to the fact that intermolecular forces of attraction between two intermolecular forces of attraction between two solute or two solvent particles are equal to those between a solute particle and a solvent particle. So option A is the right answer. Hope you understood this. Next is question number 13. It says molar conductivity decreases with increase in the concentration, and the reason is when concentration approaches 0, the molar conductivity is known as limiting molar conductivity. Okay. See, the assertion says molar conductivity decreases with increase in concentration. As the concentration decreases, molar conductivity increases. To remember, concentration decreases, molar conductivity increases. This is due to the increase in volume of a solution containing 1 mole of the electrolyte. It has been discovered that decrease in K in the on dilution of a solution is more than offset by an increase in mole. Limiting molar conductivity is the molar conductivity of the solution at infinite dilution. So you are infinitely diluting that particular solution. In other words, when the electrolyte concentration approaches 0, the molar conductivity referred to as limiting molar conductivity. So these both are correct. Molar conductivity decreases as the concentration increases, and the reason says when the concentration approaches 0, the molar conductivity is known as limiting molar conductivity. Both of them correct, but reason is not the correct explanation for. This is not the correct explanation for this given assertion. Okay. That makes both are correct. Yes, we have B as the right answer. Hope you understood this. Next is the question number 14. Transition metals show their highest oxidation state with oxygen. The reason says the ability of oxygen to form multiple bonds to metal. This is the reason for it. If I look at the options, both of them, transition metals show the highest oxidation state with oxygen. This is correct. Oxygen can stabilize high oxidation state because of its ability to form multiple bonds. Because of its ability to form multiple bonds to the metal. So this is the reason they both are correct. Option A stands to be the right answer. Hope you got that. Next is the question number 15. Chlorobenzene is resistant to nucleophilic substitution reaction at the room temperature. The reason says CCl bond gets weaker due to resonance. Okay. See, assertion is right. Chlorobenzene is resistant to nucleophilic substitution reaction at the room temperature. This is right because now the reason says CCl bonds get weaker due to resonance. See, because of resonance, chlorobenzene acquires partial double bond character. Because of this resonance, chlorobenzene acquires partial double bond character, which makes it highly reactive towards electrophilic substitution reactions. So you have the assertion is true, but this is not true. The reason is false. That makes the C option to be the right answer. Hope you got that. Let's move to the last question for the paper. That is, what are nucleic acids? Why two strands in DNA are not identical, but they are complementary? First of all, if I talk about the nucleic acids, they are naturally occurring chemical compounds that serve as naturally occurring chemical compounds that serve as primary information carrying molecules. Information carrying molecules, and the two main classes for this are DNA and RNA. Nucleic acids are long chain polymeric molecules in which the monomer, which is the repeating unit, is nucleotide. Thus, nucleic acids are also sometimes referred as polynucleotides. The two strands of DNA are held together in the helical structure. Two strands in DNA are held together in the helical structure by hydrogen bonds. Now, these hydrogen bonds are formed between specific pair of bases, like cytosine forms hydrogen bonds with guanine and adenine. Adenine forms hydrogen bonds with thymine. As a result, the two strands are complementary and not identical. So hope you are clear with this explanation. And students, with that, we have completed all the 16 questions for this set. Hope you are clear with that. And students, of course, don't forget to visit our website, www.examsnet.com. Here you will find so many entrance exam question papers along with the detailed PDF solutions. Also, you may download our app. The link is available in the description box. So students, keep shining, keep rising high. That's all for this paper. A very best of luck. Bye.